analytics in big data analytics in smart cities. I would like to call Ms. R. Srividya, co-coordinator of the Atal Faculty Development Program, to introduce our guest, Dr. C. L11.
Dr. B. Erilavan is the Managing Director and CEO of VEI Technologies Private Limited, Chennai. VEI Technologies provide a broad range of IT consulting, web application, and outsourcing services through an optimized technique. He has more than 15 years of experience in this field. He did his MBA, HR and Marketing in Annamalai University at Chidambaram and BTech CSE in Adiparashakti Engineering College, Melmarothu. He is acting as an active member in Board of Studies at NPR College of Engineering and Technology and Jnanamani College of Technology, Namakkal. He does funding projects in various colleges and conducted several sponsored FDP, national and international conference workshops. He supports many colleges to set up industry-supported lab in and around Coimbatore, Hosur and Rasipuram. He has trained more than 3,000 students by several internship programs on new emerging technologies like AI, ML, deep learning, data science, IoT, etc. The VEI Technologies has signed MOU with more than 50 colleges. I like to invite such an eminent person to handle this section. I once again welcome Dr. B. Erilavan, CEO, VEI Technologies, Chennai. Now I hand over the section to Sir. Sir, you can proceed.
Yeah, thank you for giving the chance, ma'am. So, good evening to all. So, today we are going to study basic concept of IoT, how we can use IoT in waste management system. So, first we have to talk about why we have to give attention to IoT concept. Because nowadays the IoTs are play a major role in every field. Say for example, if you take any field like agriculture, transport, medical, or whatever it is, the IoT only play major role in every field. Say for example, we will take one scenario. We will take some medical application. So the one person going to admitted in hospital in order to make some heart surgery. So what will happen? Without if the system running without IoT, what will happen after adding the IoT? What are the advantage we are facing in a real time concept? So we will take one scenario that is a hospital concept. The patient going to admitted in a hospital. So we are the doctor going to provide some heart surgery. So after completion of the surgery, the patient going to admitted in ICU ward in order to monitor the health condition, right? Which means we have to monitor the health condition, like what is the heart rate and what is the temperature. So this kind of parameter we have to monitor in order to give next step, which means in order to move to next treatment. So what kind of treatment we can go next step. So in real time, what will happen after admitting after surgery, the person going to admitted in ICU ward. So the some person allocated in order to observing the data, which means some person allocated to monitor the data, which means he's going to take the data every 30 minutes in some databases. But in real time, what will happen? The person not collecting the data proper way. So after that, what will happen? The person takes some random data, he put the data in manually. So uh, after one day or after few hours, the chief doctor will come. He will consider the data. He will monitor the data. After that, he gives some suggestion in order to go to the next step. So if the person take wrong data, which means he provided some fake data, so the treatment also going to wrong way. So that is one of the biggest problem in medical system. So if you are adding IoT system, the same scenario, what will happen? Say for example, if the person going to monitor the heart rate, so what will happen? Simply we can place some sensors inside of the patient, which means I'm going to monitor the heart rate. So I'm going to place heart rate sensor inside of the patient. The sensor will give the data. After that, the data going to updated in cloud account. So here we have to talk about some cloud account also. So we will talk about later. So first we will take the scenario. So that the heart rate data going to updated in cloud. If you are updated any data in cloud, we can easily monitor through Android app or website. So that's not a problem. We can easily monitor. So what will happen? We will get accurate data, which means we will monitor the patient health condition in live manner, which means what is the heart rate and what is the temperature and what is the ECG. So we can monitor all parameter without any fake database. So that is one of the most important in IoT system. So here we will take accurate data in order to move to next step in order to save the patient. So here, what is the main advantage? If you are putting any data in cloud account, we will get data backup also. The same technology we are using, which means we are using the IoT technology in every field like agriculture, transport, and medical, so etc. etc. So we can use IoT concept in every field. So say for example, here we are going to give attention to the waste management system, right? Fine. So here you can see some pictures. So that is nothing, that is one of the smart bin. So we are using in our day-to-day life dustbin. Okay, so what is the difference between normal dustbin and smart bin? There is a lot of features we have to discuss about it. If you are taking smart dustbin, so here we will monitor the dustbin level, right? And also we can monitor some fire status and fullness level. So we can monitor a lot
Sorry
of
to just
information.
interrupt, sir.
Yeah, ma'am.
Sir, can you make it as a full screen?
Okay. So here the simple pictures you can see here. So this is a smart dustbin. So here we can monitor the dustbin level and fire status and some status of the dustbin. Status in the sense that the dustbins are full or low level or immediate level. So we can monitor all data through IoT. So that is one of the best example for we can use IoT system in smart waste management. So next we have to talk about what is IoT. Okay. Fine. So this is a simple slide for understanding how we can use IoT in medical system. For understanding how we can use IoT in medical system, then you can easily give suggestion how we can use IoT in waste management system also, right? So here you can see some pictures. So this is a patient. So they placed some sensors, right? So they placed some sensor in order to monitor the health condition. The data going to updated in cloud account. If it updated, we can easily monitor through Android app, right? So you can see the app here. So this app, we can easily monitor the data. And next step, we will get the data backup also, right? If you are updated the data in cloud, we will retrieve the data backup also. So in this section, I'm going to teach you how to create a cloud account and how to store the data and how we can retrieve. Okay, so all the tasks we will see next, right? Okay. So next, I'm going to show you how the IoT systems are work, right? So we can talk a lot of application in various fields like medical transport, agriculture, so whatever it is. But the algorithms are same for every field, right? So here you can see some IoT stack here. So this is the steps for updating data in our cloud account. If you're understanding that stack method, you will easily analyze all kind of IoT projects, not only waste management. You can understand all kind of IoT project by understanding of this stack, right? Okay. So if you are taking any IoT project, the first step involving is a sensor, because the sensor only going to collect real-time data. So if you are taking the smart dustbin concept, so we have to use some sensor in order to monitor the dustbin level. Say for example, we will take some ultrasonic sensor or object detection sensor. The sensor only give the dustbin level, right? So here the first step is a sensor. The sensor only giving the sensor only collecting the real-time data. After that, what will happen? The data going to next step, that is a local processing. So what is the meaning of local processing? It will filter the unwanted data. Here we have to talk about what is unwanted data. In real-time application, say for example, already we talk about one example scenario, right? Medical application, right? So if anybody going to make some, medical application product, that product going to develop a lot of features, which means I'm going to make a medical application product. That product going to monitor heart rate, temperature, ECG, etc., etc. If you are going to monitor multiple parameter, we have to use multiple sensors, right? So if you're going to use multiple sensors, what will happen? That sensors are that sensors are required for power supply, right? If you're going to interface more than one power sensors, what will happen? That place will noise will generate. So that noise will affect our data. So here, what is the exact work of local processing? It will filter the unwanted data, right? Fine. And next step is the local storage. So local storage is nothing. After filtering the pure data, we have to store in local storage, which means we can use any pen drive, hard disk, so whatever it is. So what is the application of local storage? So here we have to talk about another thing. What is the main drawback of IoT? So the main drawback of IoT, without internet, we cannot do anything, right? So which means we cannot monitor the data, we cannot access the data, and we cannot control anything without internet. So that is one of the major drawback of IoT system. So here, in order to avoid the data losses, they are using some local storage. Say for an example, I'm going to collect the heart rate from the patient. What happened? That campus suddenly disconnected with the internet connection. So what will happen? The data is going to lose. So here I'm going to save the data without any losses. So that's why I'm using some local storage. It may be any hard disk or pen drive. So we can store the data. After that, what will happen? We can move to next step, which means after that we will access internet and we can update. So that's why. So depends upon the product application. You can select the local storage option are important or not. So depends upon the product. So if you are going to make any medical application product, you can use the local storage option. If you are going to make one weather monitoring project, so depends upon the data, right? So you can use that option. It is important or not. And next we have to talk about network. So here we have to talk about network. So the product collected the data, which means the product collected real-time data. The local processing will filter the pure data, which means it will filter unwanted data. After that, the data going to store in some hard disk. So next step, we have to move to, actually we have to store the data in cloud. So here we have to talk about network. Network means how we are going to provide the internet connection to the product. That product should access the internet, then only the data going to update the cloud. So here basically we know the network is a classified to two methods. One is a wired communication and another one is a wireless communication. So wired communication is one of the Ethernet cable, which means if you are going to provide the internet option through wired communication, we have to provide Ethernet cable. Or otherwise, the product going to design the portable option. It's going to move one place to another place. Now we have to use some wireless concept. Then only the product going to use correct way. So network basically classified into two methods. One is a wired communication and another one is a wireless. So wireless, we can use some Wi-Fi connection. So we can use any method, depends upon the product. Say for example, if you are going to build one ATM machine, the ATM machine going to place in static position. So that kind of product we have to provide wired communication. So next you are going to make some health monitoring product, which means the product going to carry one place to another place. So that kind of product we have to provide wireless communication. Then only the product going to portable method, right? Which means we can easily move one place to another place. So we have to use wireless. So depends upon the product application, we can select the network. So after that, what will happen? We can easily simply access the internet. Then we have to store to finally we can store the data in local storage. So here we have to talk about cloud processing. So what is in the processing? That is a simple. We are collecting multiple data, right? So say for example, we are collecting heart rate, temperature, ECG. So we are collecting multiple data. After that, what will happen? We have to separate the data. After receiving the data in cloud account, we have to separate the data in order to store correct graph, which means I'm going to show the data in graphical method. So I'm going to plot three graphs, one graph for heart rate, another one graph for temperature, and another one graph for BP. So the cloud processing will separate the data depends upon the graph method, which means it's going to update the data in correct way. So that is a cloud processing. And finally, we can store the data in cloud storage. So that is a simple example for understanding IoT. So the first step is a sensor. The sensor only collecting the real-time data. Finally, the processor, the sensor data are stored in cloud storage, right? So if you are taking any example, not only real-time project, you can take any IoT projects. That projects only running based on this stack only, right? Okay. So we move to next step. So here we have to talk about the sensor. if you are going to interface any sensor, we have to talk about what kind of sensor we have to use, which means if we are going to measure the dustbin level, we have to use correct sensor. Then only we will get the correct data. So the sensor basically classified into two methods. One is a digital sensor and another one is a analog. So we know basically what is digital. That is a that output going to provide zeros and ones, which means that is a digital sensor. So analog sensor means the sensor going to provide some floating data. It's not provide zero, it's not provide one. So it provides some floating data. Here we have to tell about the data in a voltage format. So it providing 1 to 5 depends upon the input. So that is a analog sensor. So depends upon the parameter. What are the what kind of parameter we are going to measure? So you have to select correct sensor. Say for an example, I'm going to monitor some object present, which means there is only two condition: if the object present or not. Simply, I will take some door concept. If the door is open, the light going to on. If the door is closed, the light going to off. That is our project. So here I'm going to monitor one is two state. One is a open and another one is a closed. So here we can use some digital sensor, right? Because here I'm going to use only two state. So that kind of two state application we can use digital sensor. If the door is open, the sensor will give logic 1. If the door is closed, the sensor will give logic 0. So that kind of application, we can use some digital sensor. And next, we are going to measure room temperature. So here we have to talk about the room temperature. The room temperature, room humidity, or pressure, then how to say, our voltage, current, frequency. So these are the called analog parameter. So if you are going to measure any analog parameter, we have to use only analog sensor. Then only we will get accurate data, right? So what is the conclusion? If you are going to measure two state output, we can use any digital sensor. Depends upon your application. If you are going to measure analog parameter, we have to use only analog sensor. Then only we will get accurate data. So depends upon the product, we can select the sensors, right? Okay. So next we have to talk about some platform, right? So here lot of platform is there in order to updating the IoT concept. So we people are the one of the familiar hardware is a Arduino. So we will know what is Arduino and why we are using, because the Arduino is one of the open source platforms. So nowadays all people are using Arduino. But if we are going to make any IoT project, we cannot use Arduino. What is a drawback? What is the main concept of IoT? So we have to, the IoT system is going to share the data through internet, right? Which means the internet connection is must. Then only the project going to perform. In Arduino, we cannot access the internet easiest way, right? So if you are going to say, for an example, you are going to make one temperature alarm, right? Which means you are going to monitor the room temperature through cloud. So in this project, we have to use, if you are going to use Arduino, what will happen? You will collect the temperature data, but the data we cannot update it in cloud, because the Arduino cannot access the internet. It cannot update the data in cloud. If we're going to provide internet connection, we have to use a lot of circuit in order to provide internet connection to the Arduino. So that is one of the major drawback. So next level, next controller, we have to talk about next controller. That is a ESP8266. So ESP8266 is one of the latest controller. This is also one of the Arduino family controller. So what's the difference between Arduino and ESP? Both are same, but little different only we can identify. The ESP can easily access the internet connection, right? Which means the ESP will act as a controller, as well as the ESP will act as a Wi-Fi modem, which means it can easily access the internet without any external hardware. So if you are going to build any IoT project, we have to use ESP8266 model. So in this section, I am going to show how we can use ESP8266 and how we can develop program and how use the ESP8266 for additional for making some advanced project also, right? And next we have to talk about program. So if you are taking Arduino or ESP, so both are Arduino family controller, the programming language is C. That means a embedded C, right? So if you are feeling embedded C is not good for you, if you are strong with the Python language, you are going to learn IoT with the Python concept, we can use Raspberry Pi. So the Raspberry Pi is one of the mini computer, which means that we can use Raspberry Pi for some advanced IoT project. So it will act as a mini computer. We can use Python language, but it will perform all kind of IoT process. So what is the difference between ESP and Raspberry Pi? The price will differ because if you are going to buy ESP8266, we can spend minimum 1,000 rupees. We can buy the ESP controller. If you are going to buy a Raspberry Pi, you have to spend minimum 5 to 10,000, depends upon your configuration, because the Raspberry Pi is one of the mini computer, which means it will perform all kind of tasks, which means it will perform image-based projects. It will perform some advanced image concept project also, right? So depends upon your product, you can select the IoT platform. And next we have to talk about, so this is the Arduino, right? So this is one of the Arduino familiar controller. It is one of the open source platform. So you can easily understand how we can interface sensor with our controller, but we cannot use that Arduino for IoT project. So if we are going to make any IoT project, we have to use only ESP8266, right? So this is the ESP8266 pin diagram. So here we have to talk about some GPIO, right? So what's my GPIO? It's nothing. It's a general purpose input output, which means we can easily connect external sensor with our controller. The ESP contain totally 9 GPIO, which means it's denoted D0 to D0 to D8. That is are called GPIO, which means general purpose input output. That pins are act as a bidirectional mode, which means it acts as a input as well as it will act as a output pin also. And also it containing one serial port. So serial port is nothing, it's a RX TX pin. You can find here RX D0, TX D0, which means the sensor can easily send the data to external world to the TX pin, and also it will receive the data through RX pin. And what is one of the major drawback? The ESP contain only one analog port, which means we can interface maximum only one analog sensor with our ESP. So in your project, if you are going to interface more than one analog sensor, what will happen? We cannot use ESP8266 model because it contains only one analog sensor. Say for example, in your project, you are going to measure hot temperature and humidity and pressure. These three are called analog parameters because these three parameters are analog format, which means we have to interface three analog sensors. So we cannot use ESP model because it contains only one ADC pin, that is a A0. So that kind of situation, we have to go to next level controller, which means you can go to ESP32 or ESP rover model. So in Arduino family, it contains a lot of ESP controller, latest version. So you can use advanced model in order to interface more analog sensor with our ESP. The ESP is one of the basic level controller for understanding IoT. If you are well interfacing sensor knowledge, you can go with a high level ESP controller, which means we can easily connect with our sensor. And this is some technical parameter about the ESP controller, which means it contains some Wi-Fi and Bluetooth option also, which means that model communicate through Wi-Fi network as well as Bluetooth network. Why we have to talk about this kind of feature with our controller means, if you are going to take Arduino or 8051, if you are going to interface any communication device, we have to add externally. Say for example, if you are going to make communication with the Bluetooth model, what will happen? You have to buy a one Bluetooth model and you have to make connection with the hardware. Then only the device can communicate. But here the ESP model have individual features, which means it can easily communicate with the, which means it has some inbuilt features. It inbuilt feature with the Wi-Fi connection and Bluetooth also. So that is one of the major advantage of ESP model. And next we have to talk about some, okay, fine. So next we have to talk about some technical things about Arduino. So here, what kind of controller they used? Inside of the Arduino, they are using some Atmega 328. The same features, the same technical thing available in our ESP also, right? The remaining things are same. Only what's the difference between Arduino and ESP? The GPIO will differ, so remaining things are same. So here we have to talk about operating voltage, which means the ESP and Arduino require minimum 5 voltage for its operating. And next, the recommended voltage is 7 to 12, and the input voltage limit is 6 to 20. So here we have to talk about what is recommended and what is limited. Recommended means if you are giving 6 to 12, the board will work without any problem, right? If you are giving more than 12 volt, what will happen? The board will work, but what will happen? It will generate some heat, which means the performance may be slow or it will generate lot of heat, which means it will destroy the power, which means it will waste the power in the form of heat. So that is a maximum voltage is at 20. For giving greater than 20, what will happen? The board will get damaged. So while making the PCB circuit, we have to concentrate this kind of voltage. Then only we have to complete the circuit. And next we have to talk about IO pins. IO is nothing, digital pins. Arduino totally has 14 pins, that is 0 to 13. So totally it has 14 digital pins. That 14 pins, 6 provided for PWM output. So we have to talk about what is PWM. So we know PWM is a pulse width modulation. So if you are going to control any speed of the motor, or if you are going to control uh, voltage level or current level, we have to use some PWM technique in order to control it, right? So that option also available inside of the Arduino. And next we have to talk about analog pins. Here the Arduino has totally 6 analog pins, but the ESP has only 1 analog pin. And next one is a flash memory. So it contains totally 32 KB, which means we can program up to 32 KB. And next it contains SRAM. So here we have to talk about what is the difference between flash memory and SRAM. The flash memory, which is used to store the some logical, right? If you're doing some program inside of the program, you have to use some logic, right? Like if condition, for loop, while loop. So depends upon your concept, you have to use some logical. But while doing the program, you have to declare, you can access some variable, right? So that is called a data type. So if you're declaring any data type, the data type going to occupy your RAM memory, right? So that RAM, they mentioned SRAM, the total memory is 2 KB. And next we have to talk about EEPROM. So EEPROM is nothing, it's electrically erasable program read-only memory, which is used to store some electrical data, which means the controller going to update the last status inside of the controller, then it will retain when the power is come, the controller will automatically get the old status and it continue the old task. So EEPROM also it contain that memory is a 1 KB. And next we have to talk about clock speed. So clock speed is very, very important for all controller, because the clock speed only uh, finds the controller speed, which means the controller will execute the task within 16 megahertz speed, which means if you are giving any task to the controller will do the task that megahertz frequency, right? Okay. So this is some basic technical things. That is very important for selecting the controller, depends upon your project. So what kind of project you are going to do, how many GPU you are required, then only you can select the correct controller, right? Okay. So next we have to talk about compiler. So compiler is nothing. I will show you. Wait, I will show you. Okay. Okay. So fine. Okay, so here first I will show you what project we are going to develop. Then we will go to the compiler and we will go to the program section. So remaining things. So here I'm going to make some project in order to, it's going to monitor the dustbin level, right? So for monitoring the dustbin level, we can use in market lot of sensor is there. We can use some IR sensor, ultrasonic sensor. So whatever it is, in order to, here I'm going to monitor the dustbin level. So I'm going to use some ultrasonic sensor, right? I will show the pin diagram. I'm going to show you. Okay. So this is the ultrasonic sensor which is used to measure the object detection. So we can use the sensor for measuring the dustbin level also, right? So inside of the sensor, you can find two circles here. One is a transmitter and another one is a receiver. The transmitter will transmit the signal. When you are giving the power supply and some trigger signal, what will happen? The transmitter will automatically activated. It will generate some ultrasonic waves, right? If any object present, the signal will getting reflecting. I will show another image in order to understanding the ultrasonic sensor working concept. I will show you. Okay. So for understanding the sensor working principle, you can see here. So this is only a transmitter. That chip will transmitting the IR rays. If any object present, what will happen? The signal will getting reflecting. If the signal is reflected, the data will giving to the echo pin. We will take the signal from the echo pin, and then we have to perform some calculation. Then we will get the accurate distance between sensor and object. So what is the accurate distance between sensor and object? Then we will go to next step, right? So this is the sensor working principle. So next I will show how to connect the sensor with the ESP. Fine. So this is the ESP8266 controller we have to use, right? Okay. So here already we discussed about it. So it has totally 8 pins, which means 8 digital I/O, that is denoted D0 to totally it contain 9 pin D0 to D8. So we can use any pin D0, D1, D2, it depends upon your wish. You can connect any pin. I am going to use some D5 and D6, right? I'm going to make the connection. So here we have to talk about some sensor connection before that. So VCC, it's nothing. Here we have to give power supply. I will show you. So for power supply, I'm going to, you can take any power source, like you can take power from some adapters or some regulator. So you can take any power source from there. I'm going to take 5 volt. So which means we have to give 5 volt to our VCC. And next is a ground. Ground we can make some common ground with our ESP. What is the important thing? The trigger and echo we have to connect with our ESP. Then only the controller going to understanding the sensor working, right? So I'm going to take the line from trigger pin. The trigger pin going to connect with the pin number P6. And next I'm going to connect echo pin. That echo pin going to connect with the pin number D6. So this is a connection we are going to make in real time, the sensor. So first I'm going to measure the data without any IoT concept, which means I'm going to understand the sensor working or not. If we are getting the correct data, then we will update the data in our cloud accounts. Actually, what is our final concept? I'm going to measure the dustbin level, right? So that is our final project. So here I will show the circuit diagram for what I'm going to develop. I will show the exact circuit diagram, right? Okay. So I'm going to make the connection like this. Then only. Okay. So this is the connection, right? Okay. So next we have to talk about the compiler. So compiler is nothing. It's just a software which will compile the programming language into machine level language, right? So for each and every controller has some individual compiler. Say for an example, if you are going to use 8051, we have to use scale software. If you are going to perform in PIC controller, we have to use some microchip compiler. So depends upon the controller, we have to use different compiler. The compiler will provided by the IC manufacturer, right? So here I am going to use ESP8266 model. Already told the ESP8266 model from Arduino family controller. So here we can use some Arduino IDE in order to program our ESP, right? Okay. I'm going to open ESP8266 model. Sorry, I'm going to open the Arduino compiler. I will show. Okay. Fine. So this is a compiler for making program. So what is the first step? While opening the compiler, first we have to select the controller, because the compiler can program all kind of Arduino family controller. So first we have to tell what kind of controller we are going to use in external. So here I'm going to use some ESP model. So the board name is, I'm going to show you. Go to tools option and go to board option. So here you can find lot of board families there, Arduino ESP32 and ESP8266, right? So I'm going to select Node MCU 1.0 ESP1. So that is a ESP controller name. I selected it. And next we have to program. So first we have to develop. First we have to actually what kind of programming language I'm going to use. I'm going to use C language. For I'm going to do copy paste because we don't have enough time for typing the program. So I'm going to do copy paste. Okay. So I will explain the program, right? Increase the font size. Okay. So here you can see already told we have to use only two pins. One is a trigger pin and another one is a echo pin. That echo pin was connected with pin number D6. That we can mention 12 or you can directly represent D6. Both are same meaning. And echo pins connected with D5. And next we have to talk about some, here they used some variable, they declared some value, right? So what is the meaning of that line? If you are going to interface any sensor, that kind of technical data, the sensor manufacturer will provide. Okay, so you no need to generate this kind of data yourself. While buying the sensor manufacturer will give that kind of sample data. So you just add in your program in order to get the correct data, right? And also we declared some variables names like duration, distance, and distance in inches. So that is also some data type I'm going to use in our main function. So I declared here. While considering the while main loop, you will understand what is the use of that kind of data type, right? And next you can see here, there is a void setup function. So if you are doing program inside of the controller, so we have to talk about the data direction. The data direction play major role doing the program, because what is the main role of data direction? We have to, if you are going to interface any sensor with our controller, we have to clearly mention the sensor is a input device or output device, right? Then only the controller will perform the task correct way. If you are forget to declare that, what will happen? The compiler does not throwing any error message, but finally you cannot get the output. So what is the exact meaning of void setup here? So we have to declare the sensor is a input or output. Then only the controller will perform the task, right? So here we interfaced two things. One is a trigger pin and another one is a echo pin, right? So the trigger pin is a output pin and echo pin is a input pin, which means then only the signal will getting transmitting. The transmitted signal you will get to another pin. So that's why we declared one is a input and another one is a output. Next we have to talk about they use some serial begin 11520. That is nothing. There is a serial communication. We have to enable the serial communication. And next we have to mention the baud rate. Baud rate is nothing. That's a bit per second. We can use different baud rate instead of 11520. I'm going to use 9600. You can use different multiple baud rate in order to make the serial communication, right? And next is a while loop. So while loop is a nothing, it's a main loop. Here only the main code will work, right? If you are going to develop your project, you have to develop main code inside of the while loop only, because the while loop only is a infinite loop. So here you can find some code developed here, digital write low, the same pin digital write high. You can see here we are using delay microseconds in 2, which means we are setting one bit is a low. After few microseconds delay, what will happen? The bit getting high, which means we are generating some PWM signal, which means we are giving 0101 with few seconds delay. That means the external sensor, where the external pin, what will generate? It will generate some PWM signal in order to give the signal to our ultrasonic sensor, right? That is a program for triggering the ultrasonic sensor. And next we are getting some value, the distance, duration into sound level. So that data provided by the sensor manufacturer. If you are going to interface that sensor, then you have to use the value in order to get correct data, right? And finally, after this process is completed, the data finally stored in the variable data in centimeter, and the same data stored in inch format in data inch, right? So here I printed distance in centimeter, which means I printed two value. One is the centimeter and another one is the distance, right? Okay. So this is a simple program for interfacing ultrasonic sensor with our ESP. if it work perfectly, so next we have to update the same data in our cloud account, right? Okay. So after compiling, after complete the program, we have to compile it. So go to your compiler, just to compile it. While doing program for making any error, we will get notification here. Otherwise, we will get done compiling, which means if we are getting done compiling, see, we are getting done compiling, which means there is no error. So what is the next step? We have to move to the controller in real-time sensor. So I will show you. Okay. Okay. Fine. So this is a ESP module. I think the video is visible or not? Video is visible. Okay. So this is the ESP model we have to use in real-time sensor. So this is a programming cable I have to connect here. Okay, I connected here. So after that, what will happen? We have to select the COM port, right? So go to your to Arduino file and go to your tools option and select port. Go to tools option, select port and upload the program. So while uploading the program, it will compile again. Then there is no error. It will automatically upload it. So here you can see here. So it's writing the program 0%, 10. We have to wait for up to 100%. If completed, then we will make the hardware connection. Okay, fine. Now the program successfully uploaded. Then we can see the distance data, right? Okay. See here, I will show the serial monitor function here. We can see the data through serial monitor function. So just to open here. So here you can see the data, distance in centimeters 0, distance in inches also 0, which means I did not connected any sensor. The sensor is separately here. I am not connected with the sensor. So that's why we are getting 0, 0. If it connected the sensor with the correct way, we will get some accurate distance. So I'm going to use some jumper wire in order to make the connection. So here you can find that is a first one is a VCC pin. I'm going to use some green color wire. So VCC, I'm going to give positive 5 voltage. I connected here. And next I have some 3 connector here. So I'm going to connect with remaining 3 pins. One is a trigger and another one is a FO pin. And another one is a ground pin. I connected here. Okay, so first to complete the power connection, then you can connect the remaining things. So I already connected VCC 5 volt and remaining is a ground line, that is color was red. So I'm going to use ground in order to give the complete power source. Okay, fine. Now I completed the power connection. So next we have to talk about trigger and echo. So here we have to refer our program in order to find the correct pin connection. So trigger pin should connect with the pin number D6, right? So the trigger wire is a yellow color, that which means the yellow color going to connect with the D6. So D6 connected. And next we have to talk about echo pin. The echo pin connected with the pin number D5, which means the remaining single wire, that is a orange color, I connected with the D5. Okay, now I connected a sensor. So here you can see here, now we are getting some data, right? So just to consider the centimeter 243, which means the sensor in upward direction, which means it's considered object in ceiling only, right? If you are placing any object in front of the sensor, what will happen? The sensor will give low distance. Now we can see here, the sensor centimeter is getting low, which means if any object present, the sensor will give the distance, what's the different distance between object and the sensor. Now you can see here the sensor centimeter getting low value. Better I will use some paper in order to show the demo. You can see here it's showing 5 centimeter or 2. So depends upon the, sorry, I think it's getting, okay. So depends upon the object, it will show the distance, right? Okay, fine. So which means the sensors working as correct way. So next, what is the next step? We have to update the same data in our cloud account. So here we have to talk about IoT. So here the sensor data I'm going to monitor through some app. Then only I can understand what is the dust level of the dustbin, right? Okay. So here a lot of open source platform is there, which means Blink server available. Sorry, we have to talk about some IoT open source platform. So a lot of open source platform is there. So one of the best platform for understanding IoT project. So I would ThinkSpeak, right? If you are the beginner with IoT concept, you can go with ThinkSpeak server for understanding IoT project. And next, another one open source platform is Blink, BLONK, and Adafruit. So these are the one of the open source platform for making a free project based on IoT concept. So here I am going to explain how to create a account in ThinkSpeak and how to update the sensor data in ThinkSpeak account, right? Okay. So I will show you how to create account in ThinkSpeak. So first you have to open your browser. If you are going to create any cloud account, if you are going to create IoT based project, first you have to log in your Gmail, because the all server will verify your email, then only you can create the account. So first step, you have to log in your Gmail account, then you can go to create account process. Okay, fine. I will show the screen. Okay. So here I created one Gmail account, that is aspcam405 at gmail.com, for making ThinkSpeak account, right? So I'm going to create the account in ThinkSpeak Cloud. So go to browser and just type ThinkSpeak. So you can find the first link here. Just open that. So here you can find. So go to get started for free. Just click it. Then it will ask the username and password. If you have already account, you can just simply enter the username and password, then you can log in. If you are the new with the ThinkSpeak, then you go to create one option, right? So before that, we have to talk about the pictures. So here you can find some pictures, right? So smart connected device. The smart connected device is nothing. It's just sensors. The sensors with connected with the controller. The controller going to update the data in our cloud account. The data updated in cloud account, we can simply monitor that, right? So that simple pictures, we can understand how the IoT projects are working, right? Okay. Now I'm going to create account. So go to create one option. So we have to enter the mail ID and location, and we have to enter some basic details. So I'm going to type the controller name, that is a ESP32 ESPcam 405 at gmail.com. Right? Okay. Next, we have to select the location. So here I have to select India. And next, we have to give some name. I'm going to give IoT, and next one is a projects, and give continue. So next step is very, very important, because it will generate some verification mail to our Gmail, right? So now it will asking, can I use this email for Mac work account? So just to continue, just to give continue. Now it will send some, you can see the instruction, right? So it will give some instruction. Now go to your inbox for ESPcam, then click the email we sent you, then continue, which means now we have to open our Gmail account in order to verify the email. If you are verified, then you have to come again the tab, which means you did not, if you are closed the tab, you cannot use the mail again. So you just now go to your Gmail. Okay, just to open that. Just to open that. Fine. So here you can find, so we are receiving one mail from ThinkSpeak. Just open that. You just click the verify emails. After that, what will happen? You will get your profile was verified notification. You can see here. So here in background, you can see here your profile was verified. After that, you don't do anything, just skip that line. Now go to previous tab. This means ThinkSpeak tab. Now give continue. Right. So if you are doing correct way, it will ask some password, right? So here we have to generate some password. I used some my old password and just enable the terms and condition and give continue. Right. Now we successfully signed in ThinkSpeak account. Just hit enter. Okay. So next we will ask what purpose we are making account here. Now just select student use and give some basic details. So what is the college name? It asking some details. So just to enter the random data. You no need to enter correct data. Okay. So just enter and save it. Fine. So next we have to create channel. So here we have to talk about what is channel. So if we are going to make one IoT project, some hospital, in hospital, lot of patient is there, right? So we have to create we have to create individual channel for individual patient. Say for example, if we are going to monitor health condition for patient one, we have to create channel one in order to monitor the particular data. So just to go to new channel option and give the project name. Actually, we are making some dust level project right here. So I'm going to give the project name is a dust level monitoring. Dust level monitoring system. Okay. And next, you can give some data about the project, right? What is the purpose of the project? What we'll do? So you can give some detail about the description area. So if you want, you can give. Otherwise, just leave it. And next, we have to talk about the field. So here, the ThinkSpeak account, each and every channel provided minimum 8 field in order to monitor data. So field is nothing. That is a parameter. Say for example, if you are going to make the project for health, patient health monitoring system, so how many parameter you're going to monitor? Say for example, I'm going to monitor only one parameter, just one enable the only one field. We're going to monitor two parameter like heart rate and temperature, just enable another one field. So depends upon the parameter. So how many parameter are going to monitor, just enable the field, right? So here I'm going to monitor only one field, which means I'm going to monitor the dust level. So one field is enough. I'm going to give the label dust level and finally save it. Okay. Now you can see the dashboard. The project title is Dust Level Monitoring System. I think it's a spelling mistake, right? Yes, it's a spelling mistake monitoring system. Just to go to channel settings again and make it dust level. Okay, then save again. Okay, fine. Okay, so here you can see here. So the project title is Dust Level Monitoring System and it generated some ID. So here we have to talk about some credential data. If you are creating account in any cloud account, we have to take some credential data uh, in order to connect your cloud account with our controller, which means we have to mention some credential data inside of the program. Then only the controller going to update the data, right? So the data will depends upon the cloud provider. So here we are creating account in ThinkSpeak. So here we have to talk about channel ID data and API key. If we're going to use some Blink server, here we have to use some authentication. So depends upon the cloud account, the credential data will differ. So we have to concentrate what kind of data important, right? So here we have to take channel ID and next we have to talk about the API key. So in dashboard, you can find private view, public view, and finally you can find some API key. So API key is nothing, it's a data updating credential data, right? So here you can find two key. One is a write key and another one is a read key. Here write key we have to update inside of the program because the controller only going to write the data, right? Which means the controller only going to update the data in our cloud account. So here we have to use write key. And next we have to talk about what is the use of read key, which means you can monitor, already told, if you are updating any data in cloud account, you can monitor the data through Android app as well as website, which means dashboard. So this is a dashboard option. We can monitor the data. If you are going to use if you are going to monitor the same data in ThinkSpeak value, you can just simply go to Play Store option. I will show you which app we have to use. Just simply go to Play Store option and type ThinkSpeak. Just type ThinkSpeak. So you just install that app. Okay, just install that app. After that, what will happen? It will ask some channel ID. You just enter the channel ID what we created here. So this is our channel ID. Just enter that ID. And next it will ask some credential data, which means it will ask some read key. Okay, so you can take the read key from here. The API keys option, you can find two key. One for writing data, which means we have to replace the key in our controller program, and that key we have to use in our Android app in order to monitor the data, because the app going to read the data from cloud accounts. Okay, so what process you are going to do? You have to take correct API key, right? Okay, so here we have to take that two data. Before updating the data in cloud account, we have to do manual test if the cloud is working or not. Then only you can complete the program, right? So here, how we can check the data, how we can update the data in cloud account with manually option. Then we can go to the program. That is a simple option. Go to your API key option again. So here you can find some API request here, right? By using API request, we can update the data in cloud account. We can delete and we can read, we can write, we can perform all kind of tasks by using some API request, right? Okay. So here I'm going to check the manual test, the cloud account working or not. Okay. So here you can find there is a graph. There is no data here. I'm going to update the data in manual method. So I'm going to use the API request. So here you can find the key. Sorry, here you can find the link. The last value is a field 1 equal to 0. The 0 is a data position. I'm going to hit enter. What will happen? You can see here the cloud will giving some acknowledgement, right? So it's giving data 1. So now I have to verify the graph. You can see here some data appear here, right? The data is a 0, which means you can find some additional details also, right? Which the data level and which time and which date the data is came, right? And also here you can find some entries. How many entries is there, right? So I'm going to check another data. So instead of 0, I'm going to give another one data that is a 10. Now I'm getting some additional acknowledgement, that is a 2. Again, I'm going to check the graph. Now you can see here the data was updated, which means what's the conclusion? The cloud working without any problem, which means the clouds are ready for accepting the data, right? Fine. So here we have to talk about some additional important things. So I'm going to update another one data, that is 11. Now we are getting data 11. We are getting a valid acknowledgement 3. So next I'm going to give 12. Now you can see here, now we are getting data 0. What happened? So 10 appeared and 11 also came. But last data I give 12, but it's not, but the cloud provided 0. The data also not showing here. It's not showing. So what is the reason? If anybody know? Okay. So if okay, so after giving 11, I'm giving 12. It's not accepting. So some people are thinking if are giving next data, the cloud may be not obey, but that's not a correct way. Now I'm going to give the same data again. What will happen? Now we are getting some acknowledgement, which means now we are getting valid acknowledgement 4. Now we have to check the graph. Now it's came, right? So 10, 11, and 12. The same data I give few minutes ago, it's not came. Now it's the same data again I am giving now, it's came. So what is the problem? What is the issue we are facing last time. So here we are using some open source platform. So each and every data we have to give some delay time. Without delay, what will happen? The cloud does not responding. Okay. So if we are giving one data, so next data we have to maintain minimum delay 13 seconds. Then only the cloud will accept the data. Without delay, what will happen? The cloud does not responding. I give the example again. Now I'm going to give 66. So we are getting valid acknowledgement 5. Next I'm going to give a 90. What happened? It's getting 0, which means 66 will appear. The 90 will not appear because while giving 90, we are not following the delay time. So it's providing 0. Now check your graph. The 66 is came, but the 90 is not came because without delay we are giving the data. So it's not came. I think that now the delay is exceed. Again, I'm going to give the same data. Now we are getting valid acknowledgement 6. Now check your graph. It's came, right? Fine. So this is an important thing, updating data in our cloud account. While the delay time will vary depends upon the cloud platform, right? Here we are using ThinkSpeak. So ThinkSpeak provided, they told we have to keep minimum 13 seconds for each and every data. If you are going to use Blink server, we have to keep minimum 15 seconds or 5 seconds. So depends upon the cloud provider. We have to follow the delay condition. Then only we will get accurate data without any losses, right? Fine. So that is an important thing. Okay. So next we have to talk about the program. Okay. So next we have to talk about the program, right? So I'm going to use compiler. Okay. So next we have to update the same data in our cloud account. So I'm going to do copy paste. Okay. So this is the program for now. I'm going to update the program in order to update the data in our cloud account. So here you can find some header file. So here I'm using ThinkSpeak server. So I use the header file, and I'm going to use the ESPSA Wi-Fi module. So I use that header file also. Here this is a LCD program. Here no need to use LCD. I'm just delete it. And I defined one LED. I'm going to connect with pin number D4. Right. So what is the use of LED here? After completion of the program, I will tell you. And next we have to copy some additional things. So here you can find. So I connected LED set D4, and here we have to talk about some SSID password. So SSID password is nothing. If you are going to use ESP module for your project, so we have to provide the Wi-Fi connection, which means the ESP going to access the internet the same network. For using any Wi-Fi modem in your home, you have to use your Wi-Fi SSID and password. Otherwise, if you are using your mobile phone, you have to enter your mobile hotspot name and password here, right? Fine. Next, we have to talk about some credential data. So already told, if you are using any cloud account, we have to update some credential data in our program, right? Here, we have to replace our channel ID. So now I'm going to take channel ID from my cloud account. So the channel ID is 28 something. I just to copy that. I'm going to replace here. So this is our channel ID. I copied from our channel account. And next we have to, here it will ask write API key because the controller is going to perform write option, right? So again, go to your channel settings. I will show the option where we can take the ID. Okay. So here, so we can take channel ID from here. So next we have to copy the API key. So here we have to copy the right key. Okay, we copy that, and next we have to update the key in our program. So go to your IDE. So here we have to replace. Make sure copy that and replace it. Fine. Now we replace the ID, right? And next, so this is a trigger echo already we did here. And next we have to make some functions, that is a Wi-Fi connecting concept. So I'm going to simply use paste. So go to void setup function. That. Okay, so I will explain the program, right? So this is the input output already we declared. So here I created one while loop here. Inside of the while loop, you can find some condition, Wi-Fi status. If the status is connected, what will happen? The loop will terminate. If it's not connected, what will happen? Inside of the program, I generated some LED blinking program here, which means digital right LED low high, which means if the Wi-Fi is not connected, what will happen? The device will give the blinking, which means we can easily understand the board not connected with Wi-Fi network, right? The same loop I used some serial function also in order to monitor the data in serial function, right? So this is a simple code for connecting the Wi-Fi network. If it connected perfectly, I'm printing the data's Wi-Fi is connected. Okay. Okay, so this is a next void loop, that is a main loop. So here we have to update the sensor data in our cloud account. I will show the program which code we have to use. Fine. So this is a simple program for updating the data in our cloud account, right? Okay. So here you can see two field is there. One is field 1 and field 2. We can enable field in our cloud account. So this is a data position. So first field I'm going to update the data in centimeter manner, and next field I'm going to update the data in inches, right? So these lines are update the data in our cloud account. Okay, and after completion of the process, we have to give delay minimum 13 seconds. Okay, so each and every 13 seconds, the data will automatically update in our cloud account. Fine. So next we have to compile. It's getting compiling. You can see here compiling sketch. Still it's compiling. Okay. We are getting done compiling, which means there is no error. After completion of done compiling process, we have to update the code in our hardware. So go to tools option again, go to select the port. Now port 4 defaultly selected. Everything is fine. Now upload the code. Just to click the upload button, the code will upload. Now you can see here the code getting uploading. We have to wait for 100%. Okay, the code successfully uploaded. So we have to check some serial monitor function. Okay, you can see here it's showing searching network, right? I already turned on my hotspot, so it's searching network. If it connected, it will show connected, otherwise it will show searching network only, right? So check the Wi-Fi name. Searching network, still searching. Simply I'm going to press reset button. So cross check the Wi-Fi name is right or wrong. Where is the SSID files? It's there. So this is my Wi-Fi network name. Oh, I do some spelling mistake, that's why it's not connecting. Simply replace the Wi-Fi name again. Okay, again have to upload. Actually, last time I did wrong SSID name, that's why it's still searching Wi-Fi network. I will change. If it connected, we will get Wi-Fi connected. So again, it's uploading. Fine. So we can see the serial monitor in order to know the status. If it connected, it's showing searching network. We have to wait few seconds because it will search all available network. It's searching. Wait for the password. So we have to put again. Okay. So show the serial monitor. Wait, it's not connecting. Okay, fine. Anyway, actually, there is some network issue. Actually, my Wi-Fi modem is not supporting the ESP model, so that's why it's searching. Okay, if it connected, what will happen? The sensor data will automatically updated in our cloud account. Okay. So next we have to talk about the cloud storage option. If it actually what I'm told, if it connected, so what will happen? It will get the sensor data from this function, and finally the data will stored one data in field 1 and another data in field 2. This function will updated the data in our cloud account. After that, we will getting some updating completed. Okay, so this way we will easily update the data which means we will update the dustbin level data in our cloud account, which means our ThinkSpeak account. So after updating the cloud data, we can get the data backup. I will show you how to get the data backup from our cloud account. Now just to go to your browser. Okay. So this is our browser, right? Sorry, this is our ThinkSpeak cloud account, right? Okay. So already told, if you are storing any data in cloud, that is one of the most advantage is here. We can get the data backup here. So here you can find data import export option. Then go to export option. So here we have to select the time zone. So we have to select our India time zone, I think plus 5:30. Okay, then just to do download option. So now one file was downloaded here, right? Just to open that. I'm just to expand the column here. Fine. I think it's not showing. Okay, so okay. So this is the downloaded file now. You can see here. So totally you can find three columns here. One is a date and time, which means which date the data is came, with including time, seconds, every action we are getting the data, and total entries. How many data is came? So total entry is 6 data, and what is the exact data value? So first demo purpose we are using some 0 value. After we are tested it 10, 11, 12, and 66 and 90. So this is the data. So if you are updating any data in our cloud, we can easily get the data backup here. Actually now I downloaded. So next if I download it again, we will get the same data again. While if you are doing manual delete, only we cannot access the data. If you are not delete the data, you can collect the data anytime, anywhere from the world. Just to log in the ThinkSpeak account, you can get the data backup, right? So this is one of the most advantage for updating data in our cloud account. Fine. So I think almost we completed the section. If you have any doubt, you can ask regarding IoT or sensors based on this class.
Thank you, LL, for your practical presentation.
Okay.
How will you differentiate the dustbins of decomposable and non-decomposable?
Actually, that is one of the most complicated thing because the people what they are doing, they are using some cover in order to cover all things they are put inside of the dustbin. So it is not practically possible. Actually, that is a possible. We have to make some robotic concept, which means we have to make some robotic arm in order to classify the dust. And next we have to find that is a metal thing or plastic or dry or wet. So we have to make a lot of classification here. So inside of the dustbin, we cannot make that kind of process. So we can develop the concept in a hub. Hub means dustbin collection area. So that area, we will make some robotic arms, robotic arm. We can use some lot of sensors, like we can use metal sensor, dry sensor, and that kind of sensor we can use. And then only we can classify that is a composable or not decomposable things. In dustbin, we cannot develop the concept. Can you understand what I'm saying?
Yes, sir. I got.
Participants, any questions?
Okay, sir. Thanks, ma'am. I think no queries, ma'am.
Thank you for our practical presentation, LL.
Okay, ma'am.
Participants, stay in the meeting for the next session by Mrs. C. Elilaracy.
Participants, I have posted the feedback link in the chat box. Kindly fill the feedback